Okay, everyone, let's do another video. And this one's going to talk about working with logs again, but now we're going to learn some basic log properties or rules. So let's get started. So first of all, we need to go back to exponent rules, which you learned probably as early as middle school. Does everyone agree that if I had x to the 4 times x to the 7, that's going to be x to the 11? Why? Because we learn when we multiply with exponents, that became equivalent to just simply adding the exponents, right? In other words, 4 plus 7 became 11. Likewise, here we would do 5 plus 3 to get the 8. Bottom line, with multiply, we ended up adding exponents, right? The other thing, hopefully you remember, is that if I'm dividing with exponents, we know y to the 6 over y to the 4, divided by y to the 4, that is y to the 2. Why? Because we're going to subtract here, right? Whenever I have to divide with exponents, I learned I actually subtracted them, right? And one more time, what's y to the 9 divided by y to the 2? It's y to the 7, because I basically right here did 9 minus 2 to get the 7, right? So divide again with exponents means we actually subtract them. Now, the reason why this is important to understand, guys, is because logs are inverse functions of exponent. And so therefore, they have basically the same rules in the inverse fashion. And let's just jump right into it here. Look at number 47. Notice that there is a plus right there. Well, remember, we added when it was multiply, right? So I can rewrite, notice how they're both log base 4s, by the way. So I can rewrite this as log base 4, but because there were plus in the middle there, I'm basically going to take 10 times x. Again, I made it into a multiply problem because we learned again that with adding, we actually multiply. See how the logs are the inverse rules of exponents. So now notice we have it equal to 3. Now the goal here was to get one single log function, because now, as I discussed in the previous video, could I not do a 4 power on both sides? And therefore, 10 to the x, or 10x, sorry, equals 4 to the 3. Sorry, I misspoke there. 10 to the x equals 64. 4 to the 3, remember, is 4 times 4 times 4, 64. And now when I divide by 10, x has to be 6.4. Or if we reduce this, it would be 32/5. Okay? The other thing, if you notice, we could have done, based on the other video, couldn't I have said 4 to the 3 power equals whatever this is, which is 10x. So 2 good ways to think about it, guys. And please discuss this with me in class if you're still confused by it. But we have a few more to unconfuse ourselves with. Pause the video if you need to. Look at 48 here. Notice the minus there. Well, remember, guys, with powers, whenever there was subtraction, that came from dividing, right? So, because we have a minus, couldn't I take the log base 7? Notice they're both log 7s. And because of that minus, couldn't I make it into a divide problem? So, the x here actually divides by 3. Equal to 2. Now that we have only one log function here, I can do a 7 power on both sides. 7 kills log base 7. X over 3 equals 7 squared is 49. So now all I have to do is times both sides by 3. X therefore equals 147. 49 times 3 is 147. Pause the video again if you need to. Okay, 49. Notice the plus right here. Well, let's put these logs together then. Couldn't I say it's log base 7? With a plus, I know it's going to be multiply. It equals another log over here, base 7. But no sweat, because we can get rid of these log base 7s if I do a 7 base power on them, right? So therefore, I get 10x equal to 63. This time, when I divide by 10, x is 6.3. Or if I reduce this, actually I can't reduce it, it's 63 tenths or 6 3/10. But we don't usually use mixed numbers in upper level math. So your teacher's either going to accept 63 tenths or 6.3. Okay? Pause the video if you need to. All right, on number 50, guys, now this is a little bit different variety. Something else I need to remind you of is this log here and here. Notice it's missing the base number. And what you have to remember, guys, is that when you see a log, what you're really seeing is a log base 10. Okay? This is actually the button on your calculator. So if you looked on your calculator and saw that log button, what you're really doing is log base 10. All right? So let's rewrite it with the 10 in there. Again, that's something you're just going to memorize. When you see a log without a base, it's really base 10 by default. And so because of the plus, I'm going to put these log 10s together. The log base 10 is going to be now of 2x. It's still equal to 1. So now I'm going to do a 10 base power on both sides. There goes my log 10. 2x now equals 10 to the 1 is 10. Dividing by 2, x is 5. Pause the video if you need to. Now the last two guys requires another little extra lesson. Notice these say ln. Well, ln, guys, is equivalent to natural log of n, that's what's actually spoken as, is equivalent to log base e. In other words, e is an exponential growth number that you will learn about soon if you haven't yet in your science classes. Okay? But this is another button on your calculator. Natural log, ln, is really a log function base e. E is a special number, guys. You can actually see it down here. E to the 1, you see, is 2.718. All right? But anyways, let's get to the problem. Since both of these are natural logs and there's a plus in the middle, couldn't I put them together with a multiply? That still equals 1. Now, to solve with natural log, we're going to do a e power on both sides. Because remember, natural log is log base e. So when I do the e kills off the natural log. I'm left with 3x equal to e to the 1 is e. And then I'm going to divide both sides by 3. E divided by 3, or e over 3, is your answer. If your teacher wants a decimal, as you can see here, I'm just going to put in e. And by the way, guys, remind me to show you how to do e's on your calculator if you can't figure it out. But as you can see, e divided by 3 is 0.906. Pause the video if you need to. Okay, one more, guys, and we're done for tonight. So this one, notice they're both natural logs again. I can therefore put them together as one natural log. With a plus, I'm going to use, according to the rule, a multiply, right? So 3 will times the x again. If that equals 4, now I can solve this natural log by doing a e base power on both sides. E kills off the natural log. I'm left with 3x equal to e to the 4, which means all I have to do now is divide by 3. E to the 4 divided by 3 is my answer. Again, if you want the decimal equivalent, you're going to do e to the 4 on your calculator, 54.59 and so on. You're then going to divide it by 3. There's my answer, 18.19938. And guys, that's basically the end of this lesson. There's a lot in there, so I hope you watch this video more than once. Take good notes. Remember, any notes you take is also more extra credit. Okay? But you definitely probably want to watch this video at least a couple times to absorb all this information. I'll see you in class.